So, so there were 53 possible. That didn't include the last 2 extra credit points. Now, I do have the grade book updated. So, and remember, there's a lot of points to be had in this class, including points in lab and points for homework. So, if you can't see your grade percent in the grade book, let me know, and I'll be glad to show it to you outside of class. So I was after stoichiometry is the relationship between the amounts of reactants and products in chemical reaction, as indicated by the balanced chemical equation. I was after percent yield as dividing actual by theoretical and multiplying by 100%. For C, reasons that you don't get everything back that you think you should get back. And we talked about chemical equilibria, the two-way reaction arrow. We talked about reaction rates, they're too slow, and we basically pull it before it can proceed from reactants to products. Competing reactions and unavoidable losses. Now, I didn't count it wrong, but if you put gross error, actually, misreading gross errors are not generally thought of as a way that yields are low. D, aqueous is the term that describes a physical phase where something's dissolved in water, solute dissolved in water. E, molarity is after as describing the concentration of a solution in terms of moles of solute per liter solution. F, most people did not get. Limited supply reactant was the one that you're going to run out of first. The reactant you're going to run out of first. And G, solution is another name for homogeneous mixture, kind of in context of what we've been talking about. And then for this equation, balanced equation, you need to tell me, A, what were the products, and so actually there was just one, HNO3. What were the reactant or reactants? There were 2, N2O5 and H2O. And the physical phase of water is liquid. And D, the stoichiometric coefficient in front of N2O5 is 1. And then these, I won't belabor them, we'll maybe look at here or there. I don't know if you can tell, but I changed from my my ink, my pen to pencil actually at this point, because I had to kind of erase things and go back and forth. This one, D, was probably a little challenging for people. Notice that it has oxygen in everything, so that makes it hard. Let's see, another one I thought was kind of challenging, at least for me. Where was the one that had nitrogen? Oh yeah, B. I thought B was kind of tricky, okay? But really not too bad for this section. Now remember, your final is comprehensive, and we'll be talking about your final here in a minute. So you're going to see this sort of questions that you've answered on your unit exams on your final. On to the next section. For A, I wanted you to do stoichiometric calculation from 10.0 grams of N2 to grams of NaN3. So, yeah, you can kind of see how I needed the molar mass, or you needed the molar mass of both of those things. So, and for B, it's switching up a little bit. In this case, we know the mass of the NaN3, but we're trying to get the mass of the N2. And then C actually is related to B. C says, all right, let's just say you had your 1.50 grams of NaN3, okay? And actually in B, you came up with theoretically how much N2 should be formed. Let's say instead of 0.970 grams of N2, what if we got 0.35? So here's where we put what you got, your actual yield, 0.35, divided by your theoretical yield, 0.970, times 100%. Around 2 sig figs, that's 36% yield. And then down here, a stoichiometric, a solution concentration stoichiometric problem, where we have the volume and molarity of the Na2CO3, and we need to get to, and we have the molarity of the HCl, we need to get the volume of HCl. So you can kind of see how I broke it down. We can get moles of Na2CO3, then we go from moles of that to moles of HCl, and then now that we have moles, we can use moles and molarity to get to volume.
I totally have that too. You can see where I erased it.
That's frustrating. So 4 actually had 2 parts with the same solution, the lead to carbonate. The mass was given and the total volume of the solution. And in the first case, you were supposed to come up with how is the concentration in grams per liter. So you just need to take those grams and slap it over milliliters and then fix the liters, okay, for the first one. And then for the next one, for the same solution, what's the molarity? So for this one, you needed to convert from grams to moles. So you need to calculate the molar mass of lead to carbonate. Yep.
Just curious, why did it go from 7 back to 4?
Must just have been an editing thing for me. Sometimes it like has auto number and then it has a mind of its own. Good question. I wonder if my pages got mixed up, because is this 3? Yeah, it kind of looks like the pages were turned around. Is everybody like that? Yeah. Yep. You should be an editor. So for the next one, it was involving sodium chloride solution, and the molarity is known, and you needed to know what grams you would need to dissolve in 500 milliliters of solution to get that particular molarity. So you can see what I did. I took the volume of interest and I converted it from milliliters to liters, and then once I had liters, I used molarity to see how many moles I would need to dissolve. Okay. And then once I had it in moles, I used the molar mass of the sodium chloride to get to grams. So, and then the last two, this was not one of my better extra credit points. I think this would have been really hard for you guys to get.
It was super hard. I
yeah.
thought I was putting titrant for both of them because I wasn't sure.
Yeah, I know. It was this semester, that's just kind of the way things fell into place with regard to titrations. But in that extra, which I did give everybody 20 points towards assignment points for doing those titrations in lab the other day. So the stuff you put in the burette is the titrant, and the stuff you're dripping it into is the analyte. So that's kind of what that is.